Spaceborne Computer 2 is the latest available edge computing resources on the International Space Station. We had to survive the shake, rattle, and roll of launch. We had to properly package it so that it could be stored properly, and we had to come up with the instruction set on how it would be installed by our astronauts. The latency from space on the International Space Station is significant. It takes a very long time to get the data from the International Space Station back to Earth.
The space station has limited bandwidth. We are only allowed to use 2 megabytes per second for only 2 hours per week. So that means if you're running experiments that uses a lot of data, you can't send all your data down to Earth. You need to do some processing using the power of HPE's Spaceborne Computer 2. Take a look at your data and distill it down to what's interesting. Then you can send down interesting events down to Earth, where you can then leverage the power of Azure and the public cloud to process at scale. With that, we can also bring tools to bear such as Microsoft Genomics. And we take that sequencing data and see, is there anything interesting that we need to tell the astronauts about what we have seen?
One of the great things about Spaceborne Computer 2 being developed with an open source software is that here on Earth, it's really cool that for me as a developer, I can use those same tools. It really increases the developer velocity to creating something useful. So I can know with confidence that, say I go to the repository for this project, I can clone it from GitHub, I can open it in a browser with GitHub code spaces, or I can open the solution with Visual Studio Code, build it with Docker, and I have the exact same tools that I know are going to be present in the Spaceborne Computer 2. So I can validate, dev, and test locally, deploy to Azure, and deploy to space confidently. It's cool that we can take patterns that we know exist today, repeat them, stand on the shoulders of the giants that came before us, and build better things.
With stuff that every developer knows how to work with, building on open source components of Linux and Docker containers means that there's a much wider group of developers that can develop applications that are meaningful in space.
Open source technologies allow us to create unique and interesting things, and then Spaceborne Computer 2 gives us the horsepower to do them.
By conducting experiments with off-the-shelf technologies on the HPE Spaceborne Computer 2, we can prepare for missions that are further out. So if we're preparing to put humans on the moon or on Mars, we want to know how we can build these patterns of processing at the edge and bursting down to the cloud now while we have the space station before we go to much further and more difficult places. I'm looking forward to seeing how Microsoft brings our experience with democratizing the technology to help bring space out to every industry.
When we build these things today, our hope is that we can build truly game-changing things in the future for both astronauts on board, our partners, and the people here back on Earth.